we're going to review flowcharts, and we're going to do triangle congruence proofs. So hopefully, again, that we remember this from Integrated 1. A couple of things I would ask you to kind of keep an eye on and try and remember is look for right angles. And if you see them, see if the Pythagorean theorem or the hypotenuse leg might come into play there. Look for reflexive sides. Look for vertical angles. If lines are parallel, think about, again, not the sides, but the angles. See if there's alternate interior angles or corresponding angles that might be congruent. And then when we're done marking all this stuff, then we'll go back and look and see if we can prove triangle congruence. So just some thoughts to keep in mind as we do this. It helps to have a strategy as we go through. So let's go ahead and jump into this and see what we come up with. Let me pause and set this up. Do flowcharts for congruence. Now that you have reviewed the shortcuts for establishing triangle congruence, how can you organize information in a flowchart to show the triangles are congruent? So consider this question as you work with your team today. Are these triangles congruent? Well, to me, it looks like they have all three of the same side lengths, which would mean that side congruence is probably true. So we get off to a pretty easy start. So I'd say yes, they are, because of side congruence. Now it says make a flowchart showing your argument that these triangles are congruent. Now, I don't know, obviously if you had Mrs. Baldwin, or I guess it doesn't really matter depending on when you're watching this video who the teachers are in Escalon. The bottom line is that there's a chance that you were shown flowcharts. There's a chance that you've seen proofs. So I'm going to do this both ways just in case. So flowchart essentially means you put the fact in the middle of the bubble and the evidence outside of it. So I'd say, hey, look, AB is congruent, and there's so many different ways we can write this, to FD. Actually, this isn't even correct the way we should be doing this, but this is pretty much the way the book does it, and we know that that's given because they're both 6. So actually what we should say is AB is congruent to 6, or is equal to 6. That's given. And then we should say DF is equal to 6, and that's given. And then we can say AB is congruent to FD because of substitution or because of reflective property. But we don't really do it that way. So again, I'm going to sort of ignore all this, and we're going to go back to, I just always feel the need to sort of throw that out there, that this is not the way that I was taught, and that they're leaving stuff out in this book. So as long as we're okay agreeing to that, then I guess it's okay to do. I just am uncomfortable. It doesn't jibe with what I was taught. All right, so AC is going to be congruent to EF. And again, we know that because of given. And then we know BC is going to be congruent to ED. And again, we know that because it is given. So we can say a triangle, again, it's kind of irrelevant. Triangle ABC is congruent. This part very much matters. A is across from 4.5, so I'll go with F is across from 4.5. B is across from 7.5, so I'll go with D next. And C is across from 6, so I'll go with E. And finally, I know that's true because of side congruence. And again, if you wanted to do a 2-column proof, it's the exact same thing. On the left side, you put the fact, and on the right side, you put the evidence. So here, the fact AB is congruent to DF. We know that's true because it's given. Here, AC is congruent to EF. We know that's true because it's given. Here, BC is congruent to ED. Because it's given. And now we'll say finally triangle ABC is congruent to triangle FDE because of side congruence. Now, I will say this. If you know this, that's great. Feel free to use proofs. I don't care. If you don't know this, I'm probably going to use flowcharts because later in the book it introduces proofs. I just want everybody to recognize they're the same. If you're not comfortable with this, don't worry about it. It will be introduced later. If I do this, it shouldn't freak you out. You should definitely know how to kind of compare to see if you did the right thing anyway. So again, it's sort of up to you. I just want to be clear for everybody's sake that these are the same thing. They have the same information. I just know some teachers jump straight into proofs. Some teachers stay in flowcharts. And as an integrated 2 teacher, I have to kind of try and marry the two together. So if you already know this, shouldn't be a big deal to go backwards in time. If you don't know this, probably more comfortable for you to stay here, which is probably what I'm going to go ahead and do. Because like I said, eventually we'll get to proofs anyway. So sorry for the long-windedness. I feel like that took a long time. There's a lot about this book that I like, but there's a lot about this book that leads something to be desired. So let's go to make a flow chart that the triangles below are congruent. So again, I'm looking for certain things here. I'm not seeing any right triangles. Any right angles. I'm not seeing any reflexive sides, but I do see some vertical angles right here. So these are definitely vertical angles right there. I don't have any parallel sides. So is this enough to prove triangle congruence? Well, angle, angle, side, angle, angle, side. You'll notice they correspond. The 6 is across from the 1 tick. The 6 is across from the 1 tick. So yeah, I think I do have enough to prove triangle congruence here. So what I will do is I will say QP, and again, this is absolutely incorrect, but we're agreeing to do it this way anyways, is congruent to ST. So QP is congruent to ST because it's given. It's given that they both equal 6. I can say angle P is congruent to angle T. I know that they both equal 120 degrees. I should say they both equal 120 degrees, and that's why they both equal each other. But again, this book doesn't really do that. Sometimes it does, sometimes it doesn't. It's just easier to ignore. As far as naming this angle using one letter, I hope we understand why we can use one letter here instead of 3 letters. If you want to call it QPR, RPQ, it would not be wrong, but there's only one angle here, so we are allowed to use one letter. When I go to R, there's multiple angles, so I have to use 3 letters here. So I will say angle PRQ or QRP. It doesn't matter. Either way, PRQ. Either way, you'll notice in the middle is the R and in the vertex is the R because I want to say this angle, right? That R has to be in the middle, and SRT. And again, I hope that we all remember this from Integrated 1, because if we don't, we need to ask questions and make sure we're all on the same page. And we know that's true because these are vertical angles. So vertical angles. And now I can say triangle PRQ is congruent to triangle, again, P is 120, T is 120, R has 1 tick, R has 1 tick, Q is unmarked, S is unmarked. So we will say that. And again, we already know this is true because of angle, angle, side. And I mean, I guess we did side, angle, side. It's not truly important. As long as we did it correctly, we should be fine. Oh boy, I feel like these are not the way to start with these, but it is what it is. We'll keep going. So suppose that you're working on a problem involving 2 triangles, triangle UVW and XYZ, and you know that UVW is congruent to XYZ. What can you conclude about the sides and angles of UVW and XYZ? Write down every congruent statement involving sides or angles that must be true. Well, I know the angle U must be congruent to angle X because they're in the first spots. I know that angle V must be congruent to angle Y because they're in the first spots. And I know that angle W must be congruent to angle Z because they're in the third spot. I think I said first spot here, I meant second. So first spot, second spot, third spot. I know that UV, side UV, is congruent to side XY, again because they're in the first spots, first two. I know that VW and YZ go together, so side VW is congruent to side YZ because they're in the second and third slots. And finally, I know UW has to be congruent first third to XZ, first third. So I know these 3 angles are the same and these 3 sides are the same. CPCTC, if the triangles are congruent, the parts are congruent. That's going to be a big deal later, we'll talk about. All right, so it says Callie started to prove that given information, diagram it right, AB is congruent to CD. Okay, so she wants to prove this side. Copy your flowchart below on your paper to help her by justifying each statement. So, okay. So before we do, I just want to make sure that we understand here. They told us the triangles were congruent, and if the triangles are congruent, that means the parts are also congruent. Excuse me, let me check something real quickly. Big deal. The fact that if the triangles are congruent, that the parts are congruent. And we're going to use that logic here. We're going to say, hey, look, I'm trying to prove that AB is congruent to side CD. And there's really nothing that tells me AB and CD are the same, but what if I can prove these triangles are the same? If these triangles are the same, then I can say all the parts are the same. And here's what I mean by that. If I take these two triangles, and I say, hey, look, these two triangles are the exact same shape and the exact same size. What does X equal? Well, if these are the exact same shape and the exact same size, and you already know these triangles are exactly the same, that means the parts have to be the same as well. These 5s match up, these 6s match up, these 7s have to match up. You would know automatically that this is 7. So that's the logic that we're going to use, that if we prove that the triangles are the same, then the extra parts that we didn't prove must also be the same. It's known as CPCTC. It's going to be a huge deal later in this book. We're just sort of setting it up right now. Again, this comes from Integrated 1 as well, so hopefully you remember this. So how do I know AD is parallel to BC? I know it's given by ticks. You'll see those ticks right there. They'll say those are parallel. And who cares if those are parallel? Well, what does that tell me about angle ADB and about angle CBD? And you'll notice these have a tick here. These I will leave with no ticks. Well, I know that these angles have to be the same because of alternate interior angles, right? Those are alternate interior angles. So if the sides are parallel, which they are, then the alternate interior angles are congruent, so those are congruent. Well, how do I know that A and C are the same? Well, that's given by ticks. How do I know that BD and BD is the same? Side BD and BD, side BD? That's got to be reflexive, right? That's the same side twice. So now I can say, hey, look, I know triangle ABD and CBD are the same. ADB and CBD are the same. How do I know that? Because of angle, angle, side, angle, angle, side. So I know this is true because of angle, angle, side congruence. And now that I know that these triangles are the same shape and size, what does that say about this last piece right here, AB and CD? Well, I know they have to be the same because of CPCTC. And again, CPCTC stands for the following. Let me type this up. I think it would make more sense. Corresponding parts of congruent triangles are congruent. So the corresponding parts, this part is across from the one tick, this part is across from the one tick. The corresponding parts of these congruent triangles, I prove these triangles are congruent, are also congruent. They're also equal to each other. Again, this is going to be a big deal later on as the year goes, but we just call it CPCTC. All right, so it says each diagram below determine whether the triangles are congruent or not. If you claim the triangles are congruent, make a flowchart. So how about this? Again, we're going to go through and look at these things here. Are there any right angles? There are no right angles, so I don't have to worry about the Pythagorean theorem or the hypotenuse leg. Are there reflexive sides? Yeah, I see a reflexive side right there. Are there any vertical angles? No vertical angles, but there are parallel lines. And anytime I see a parallel line, I want to be thinking about angle relationships, and I have some alternate interior angles there. So you can see these are true because these are congruent because of angle, angle, side, right? So I can make a flowchart. In my flowchart, I'm going to say that I know that angle B is congruent to angle D. I know that because it's given. I can say that angle BAC, and again, I hope we're getting comfortable enough with this, enough to understand why we have to use 3 letters here, but we only need 1 here. Only 1 angle here, but multiple angles here, so I need to be very clear. BAC is congruent to DCA. And how do I know that? Well, those are alternate interior angles. For now, we'll just say alternate interior angles. Later in the chapter, we'll learn that we need to say if the sides are parallel, but for now we'll just say alternate interior angles. And finally, I know AC is congruent to AC. And how do I know that AC is congruent to AC? Well, those sides are reflexive. So you can see all these things sort of come together, and it allows me to say that triangle DAC is congruent to triangle D has one tick, B has one tick. A is unmarked in this triangle, so I have to go with C because C is unmarked. In this triangle, C has 2 marks, and in this triangle, A has 2 marks. So again, we see where the A and the C flip spots. And we know that's true because, again, angle, angle, side. The side does not connect these angles, so it's not angle, side, angle. It is angle, angle, side congruence. All right, so if we go here, let's take a look at this one. We don't have any right angles. We don't have any reflexive sides. We do have vertical angles, so I know these angles have to be the same. We have no parallel lines, so it doesn't look like these are congruent, right? I mean, I have the angles are the same, but the sides in corresponding spots, right? Across from one tick is 5, so across from one tick should be 5, and it's not. So I would say not congruent. Let me go ahead and pause and set up the next problem. See, again, I'm going to go through that list there. Do I see any right angles? I do see right angles, so I'm going to see if I can use the Pythagorean theorem. 2 squared plus 3 squared equals this, and 3 squared plus 6 squared equals this. So let's go ahead and grab our calculator here. And I'm going to say 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So the square root of 13 equals 3.6. So this is about 3.6, right? And then here, 3 squared plus 6 squared. Well, I know 3 squared is 9, plus 6 squared is 36. So I want the square root of 45. So the square root of 45 equals 6.7. So I think it's pretty obvious at this point that these are not congruent, right? A 2, 3, 3.6 triangle is not the same size as a 3, 6, 6.7 triangle. So I'll say not congruent here. What about this one? Do I have a right triangle? I do. So let's go ahead and use the Pythagorean theorem to see if we can figure out the missing side. Because right now I think we can agree. I have the 13s the same. I have the 90-degree angles the same, but I don't have another side that's the same, and I don't know any angles. So I'm going to say, again, the hypotenuse is always by itself. So 5 squared plus x squared equals 13 squared. So 5 squared plus x squared equals 13 squared. 5 squared plus x squared equals 13 squared on this one. This one should be 12 squared plus y squared equals 13 squared. So let's go ahead and see here. 25 plus x squared equals 169. Subtract 25 from each side. X equals 12. So this length is 12. On this one right here, I have 144 plus y squared equals 169. Sorry, my writing is so sloppy. Y squared equals 25, so y equals 5. So there we go. I'm going to go ahead and just clean this up a little bit with that 12 and that 5 to make this look a little more clean. But you can see we do have triangle congruence, right? Obviously, side, side, side works. Not only does side, side, side work, but you could also use hypotenuse leg on this one, or you could use side, angle, side. So again, if we only chose to look at, let's pretend we just chose to look at, let me do this. If we just chose to look at the sides, we would say side, side, side. We can use side, side, side triangle congruence. Or let's pretend that we chose to ignore the 5s. And you can see I have a 90-degree angle. The hypotenuse is the same. And one set of legs is the same. So I could use hypotenuse leg if I wanted. Or let's pretend that I wanted to ignore the hypotenuse. I could go side, angle, side, and side, angle, side. So there's literally 3 different ways I can use to prove triangle congruence. And the reason why I can use 3 is because I had to do some math on my own. The fact that I had to calculate this 12 and this 5 opened it up to so many different ways of doing the flowchart. So it's up to you which one you want to do. To me, I don't know, let's just do side, side, side since we chose that one first. So we can say MK is congruent to RQ. And we can say that's true because it's given, right? We didn't have to do any math for the 13s. We could say ML is congruent to PQ. There's a bunch of different ways we can say this. We can say the Pythagorean theorem, math. I'm just going to say math. We did some math here. We used Pythagorean theorem to figure out this was 5 and those are the same. That's fine. And then KL is congruent to PR. Again, same thing. We knew this 12 here, but we had to use math to get this one, so we'll just say math again. And now I'm just going to finish up by saying triangle KML is congruent to triangle K is across from the 5, so I'll go with the R is across from the 5. M is across from the 12, so I'll say the Q is across from the 12. And L is across from 13, so I'll go with P is across from the 13. And again, we will say that this is true because of side, side, side. Let me do the hypotenuse leg one real quickly, just because a lot of times kids have questions with it. What would it look like if you had done a hypotenuse leg instead? Kids generally seem to have an understanding for side angle side. That's pretty simple, but the hypotenuse leg can be a little bit trickier. So if you want to prove hypotenuse leg, there's a few things that you have to prove. First of all, you have to prove right angle. So we're going to say angle L is congruent to angle P, which is equal to 90 degrees, and we know that that's given. Now we're going to say that we have to prove a hypotenuse, right? So we'll say MK and QR, because that will prove our hypotenuse. So MK is congruent to QR. That was given. And then the last thing is we have to prove one of the legs. It doesn't matter if you say ML and PQ, or if you say KL and RP, but you have to prove one of the legs. So I'll just say ML. I think I said that one first. ML and PQ, and we know that because of math. And now we've proven a 90-degree angle. The hypotenuse are the same, and the leg is the same. So I'll say triangle KML is congruent to triangle RQP. But this time we didn't use side, side, side. This time we used hypotenuse leg. So either of these is totally acceptable. And again, you can also make one for side angle side that would also be totally acceptable. Let me pause real quick and see if there's anything else I want to mention before I turn this video off. Mention again, this book does a good job of ignoring symmetric and transitive. Those are real properties that I really had to deal with when I took geometry in high school, but this book essentially ignores them, but it does do some reflexive property. So make sure that you understand the reflexive property, fill this section in. Again, triangle congruence, I almost regret not putting on this note sheet, maybe put it off to the side. It will definitely show up, CPCTC, corresponding parts are congruent, triangles are congruent. That's also important. I think it'll show up more later, and I think I put it in the notes in a later chapter because we do move into triangle similarity and we sort of deviate from triangle congruence. So just worth kind of considering that. All right, that is that for 212.